Hello everyone, I am Pranav Jain and today we are going to implement stack. So basically what are stack? Stack are basically LIFO data structures which says last in first out, which means whatever element is inserted, it is inserted at the last of the list, and whenever we want to pop something out, we want to delete something, then that is done at the end itself, at the very end itself. We can call it the top, or we can call it the end, or we can call it anyway, but the thumb rule is we can only insert and delete at the same side of the list. Okay, what I mean is, let me show you. So let's suppose this is our stack. I insert element 1 here, I insert 2 here, I insert 3 here, and then if I insert 4, it would be inserted here. If I insert more elements, it would be inserted at the top of each other. Okay, so whenever I will delete something from this stack, I cannot delete this or this or this. I can only delete or pop this element here at the top of the stack. So when I delete this element out of the stack, then this is my top element. Then if I want to delete more from this stack, I can delete this. So this is last in first out. In the last I put this element, and this is the first one to get out of this stack. Then this element is popped out, then this, and then our stack is empty. So this is LIFO data structure. Okay, uh, so we can implement it using array, we can implement it using linked list as well. Let's in this, let's start with array. So uh, let's suppose if I have an array, if I go in my array implementation class and I have this array, I want to insert and delete from this array, right? So what I can do, I can create methods insert at beginning and delete at beginning, right? I The thumb rule is we can only insert or delete only from one side of the list, either it at the beginning or either it be the end. So if I consider beginning as the top of my stack, so I'm going to insert elements in the beginning of the linked list. Now if I want to insert a new element, I would insert it here, I would insert here. For this I would have to shift each element one to the right. That would take the complexity of n, right? Here it would take n number of times to finally insert in the beginning. Similarly, if we want to delete from the beginning, what will happen? If I delete this, I have to shift all these to the left. This will also take n complexity, as we can see in this implementation. Delete at beginning. By the way, if you guys are not aware of insertion and deletion in an array, you can see my previous video on array and have a good grasp on that. You can find the video in the cards above. Now moving ahead, so the other way we can implement stack using arrays, if we insert it at the end of the list and delete at the end. So if I have to insert at the end 6, I can just simply insert at the end like this. I know the size, I know the capacity. So if you see insert at end, there is no for loop here. We simply insert at the end in O1 complexity, right? So insertion at the end and even deletion at the end. In deletion we simply decrement the size by 1. Our size pointer would be here, as you can see in this delete at end. So deletion at end also takes O1 complexity. So we will be implementing stack using array, and the methods we are going to use is delete and insert at the end. Okay, so we can recreate all this or we can reuse our code, which should be the ideal case. The size here can be considered as top. What I mean by this is, let me refactor this as top. So now initially the top of my stack is -1, right? So when I insert at end, what I simply do, array of top plus 1, array of 0 will be equal to element, and I increase it by 1. Or I can just simply write it this way as well, like plus plus top, and remove this. So this is one and the same thing. This will increment our top pointer to 1 and insert our element at that position, right? So this is our insertion at the end of the stack. And for deletion at the end, what we are simply doing, if our top is -1, that means already we have the underflow condition, and if not, we simply decrement the top. As simple as that. So for now we are keeping it as size only. Actually these should be private. Okay, so we have created, we can simply create a push and pop using insert at end and delete at end methods of this array. Let's do this. Let's create our push method. We call it push operation in stack whenever we insert. So we are inserting, so we are calling it private void push int element. We are considering each element as integer type. It can be any object whatsoever. So let's declare a class object of array impl let's call it array stack equals to new array impl, and we can simply write array stack dot insert okay. So we have to make our methods public here. We have made this private, right? So we cannot access this method here. We have to make it public, or if we have this stack input class in the same package, we can also make it default. For now let's keep it public, and also delete at position as public, and we would need to print this also. This is a utility method for printing the array. So now we can simply insert at end. Okay, this will handle our push condition. Now let's create a method for deleting from the stack. For deleting, we call it a pop operation, and we know pop operation can be done only at the end of the stack or the array. Okay, sorry, so we have created wrong method as public. Deleted pause can remain private, and deleted end, we need this method. Okay, actually all these methods can be public. So delete at end. This method is also done. Okay, now we may also write some utility methods for this, like let's check if our stack is empty or not. So for checking if our stack is empty, we can simply add a utility method here which will check if this top or size is -1. If this is -1, that means our stack or array is empty. So we'll simply return true or false on the basis of this. Let's implement this. Public void, oh not void, this time we need to return a boolean. Boolean is empty. Okay, so if my top, which is size, is equal to -1, this means I'm going to return true, else I'm going to return false. Or we can simplify this condition by the ternary operator, like return if size equal to -1, then return true, else return false. This is same as this. So all our extra boilerplate code is removed. Okay, so this is our is empty method. What if we want to check what is the element at the top of the stack? What is the current element which if pop operation is performed will be deleted? So we can write that as uh, peak method or top method. Let's call it peak method. Public int peak. So if my array is empty, if top is -1, we can simply use if is empty. Then we can just simply say that it is the empty stack, and we are going to return a default value. Let's say -111 signify that uh, signify that we have empty stack, we don't have anything in it. Else we can write return the top element of the array. Okay, let's simplify this condition as well. Return if is empty, right? We can write directly top equals to -1 as well here, size equals to -1 as well. So let's use this for now. And these are two utility methods that we have created new in this array implementation, and we are going to use them in our stack. We can simply write, actually these methods should not be private, these should be public. So public int peak array stack dot peak, and we will return this. And our is empty method should also be there in stack. This can simply call array stack dot is empty, right? So let's check our methods. Let's change it to public. and in the main method we can simply test it. Okay, so let's push element 1. Okay, so currently, okay, we haven't implemented print method. Let's implement that also. Actually, we can work with the peek method also, but also implement print for now. And we will simply say stack array stack dot print dot print method, and we can also now delete. We should peek what is the element that we are going to delete, and then we are going to pop that, and then let's again uh, print it, and in the end let's check stack dot is empty. Before this, let's pop twice, and let's run our test. So what we have got, 1 2 3 we have pushed and print, so 1 2 3 is printed, right? Then we say stack dot peek. Okay, so we have returned this peek but we haven't printed it. Let's print this as well. Simply print this, and let's also print this is empty. This will print true or false. Okay, so we inserted 3 elements, we printed that, then we peek. So 3 is the last element, we get 3 as the peek element. Then we popped 1 element, we get 1 2. Then we pop 2 elements, which is 2 1, and checked if it is empty. Yes, it is empty, so it returns true. So this is our implementation of stack using array. That's it for this video. In the next video we will be implementing stacks using linked list.